Alright guys, so this is the second part of sketching parabolas. And in this video we're going to be using the form y equals a outside of x plus b squared plus c to actually sketch a quadratic. Alright, in the last video I showed us how to get from a normal quadratic form to this a outside of x plus b squared plus c form. And I'll go into a little bit of depth now about why we want it in this form. So we can see here, it gives us a few bits of information that we can just extract straight out of this form that we wouldn't be able to do in any other form, right? So we can see here that this a value actually gives us the vertical stretch or compression of our, in the y direction of our function, right? So if a is larger than 1, we're going to find that it's going to be stretched out vertically, okay? And it's going to have a sharper turning point, right? So it's going to be, the two sides are going to be in closer together. Whereas if a is between 0 and 1, it's going to compress it vertically and make it a little bit fatter at that turning point, open it up a bit. Okay, so also if a is negative, as you can see here by my smiley face and sad face, it'll flip it over. So for a positive a value, we get this smiley face here looking parabola. And if it's negative, it flips it over and gives us like a frowny face looking parabola. All right. So secondly, b is our horizontal translation. So this little value in here tells us how much we shift left or right. And if b is negative, then we shift to the right. And if it's positive, then we shift to the left. Okay, thirdly, c is our vertical translation, okay, and that tells us how far up or down the graph we're going to move. So if c is negative, we'll find ourselves moving the graph down, but if it's positive, we'll find ourselves moving it upwards, all right? And probably the coolest thing about this form here is that we can automatically, or straight away, we can extract our turning point, or the coordinate of our turning point, and it's going to be located at negative b, c, where that is the x coordinate and that is the y coordinate. Alright, so that's all we need to know. Let's jump into sketching. Okay, so the example we're going to be doing is the same one as we did in the previous video. And so let's just recap that real quick. They want us to express the quadratic y equals 3x squared minus 5x plus 2 in the form y equals a outside of x plus b squared plus c. And so when we expressed this in this form here by completing the square, we found that y is equal to 3 outside of x minus 5 on 6 squared minus 1 on 12. Okay? So this is the function that we're going to be using partly to sketch our graph. Okay, so straight away, by comparing it to this function up here, we can see that a is equal to 3, b is equal to negative 5 on 6, and c is equal to negative 1 on 12, okay? So the next step we're going to do is we're going to write short statements as to what a, b, and c do. How do they affect our graph, okay? So the first statement I'm going to write is a stretches the graph by a factor of 3, okay? All right, and I've also added in this little header up here as a bit more communication, just saying this graph is, so then we can make these statements all shorter down here. So what I've said is this graph is stretched by a factor of 3 vertically. Because remember before, we said if a is larger than 1, we're going to get a vertical stretch. Yeah? All right, so b is our horizontal translation, okay? And so because b is negative 5 on 6, we're going to find that our graph is going to be translated to the right 5 on 6 units. Okay, so translated right 5 on 6 units. Now our c value is negative 1 on 12. Okay, so that negative means we're going to move down, and we're going to move down by 1 on 12 units. So we've done that. Okay. Now that are our statements done. Remember that if a is negative, you need to make a statement that it will be inverted. Okay? All right. So now we move on to our turning point, all right? Now remember I showed you before that our turning point is super easy to get from this form, okay? So remember, we look up here and we say our turning point is at negative BC, all right? So negative BC for us in this case here with this quadratic in this form is going to be negative 5 on 6, so 5 on 6, and then negative 1 on 12 is our C value. So that is the X and Y coordinate of our turning point. All right, super easy. Next step, we want the X and Y intercept, sorry. So Y-intercept we find by letting X equal 0, all right? Now for this, we actually go back up here to this form because it's easier to use, all right? So we're actually done. We've gotten all of our information that's useful to us from this form here, and we're going back up here to find the X and Y intercepts, okay? So they're very simple. We just let X equal 0. So that means when we do that, we get Y equals 3 outside of 0 squared minus 5 times 0 plus 2. And that gives us Y equals 2. So Y equals 2 is our X-intercept, okay? Now our Y-intercept. So what's our X-intercept? Our X-intercept, to find that, we let Y equal 0, okay? So if Y equals 0, we get 0 equals 3x squared minus 5x plus 2. So you can use multiple methods to solve this quadratic equation, completing the square, you could factorize. So you can try any of those methods, but I already know what the answer is, and that is x equals 2 on 3 and x equals 1. All right? So those are our two x-intercepts. And that is all the information we need to graph. So let's go do that. Okay, let's do it. So the first step in sketching our graph, or the first information we want to put on our graph, is the turning point, okay? It gives us a basis to work from. So our turning point is at this coordinate here. So we want to go 5 on 6 along the x-axis, which is about here. And then we want to go down 1 on 12 units, which is about here. So if we put that across, they line up there, okay? Now we go to our x-intercepts. And we can see that our graph intercepts the x-axis at 2 on 3 and 1. So there's 1, and 2 on 3 is about there, 2/3. All right, and finally our y-intercept. Our y-intercept is at y equals 2. So put that on there as well. All right, and now all we do is we connect the dots. So start a little bit higher up here and just bring it down and try and get a nice natural curve up, okay? And there we go, that's our quadratic sketched. Some teachers might like you to label it and put what function it is. So our function is 3x squared minus 5x plus 2. And then we're done.